Here's what I wanted to do, you guys. What we're going to do first, I don't know why my pages are all off, but here we go. We are going to start graphing these functions, and here's what we got to be familiar with. Do you guys remember what we call this little guy?
We're not doing it.
What kind of asymptote? A vertical asymptote and a horizontal asymptote or a slant asymptote. Here's the deal. I'm not going to make us find slant asymptotes. Are we down with that? We're down with that. Okay, a vertical asymptote, the slope of a vertical asymptote. What's the slope of any vertical line, Vux? Oh, I didn't say Vox. I said Vux. Yeah. So we're going to say it's undefined. A rational function is undefined, so a fraction is undefined when the blank equals 0. Denominator, yeah. When the denominator, that's the one on the bottom, equals 0. Vertical asymptotes, are blank crossed. Will we ever cross a vertical asymptote? To that I say, no ma'am. No ma'am. So they are never crossed. Bless you. So every time it said, in order to find a vertical asymptote, every single time, you just set the denominator equal to 0 to find your vertical asymptote every single time. So our notes, we're going to kind of skippity through these a little bit because I just want to focus on vertical asymptotes for a second. So the vertical asymptote for this guy, you set the denominator equal to 0 every time. When is x plus 2 equal 0? At -2. So you guys, Vux, again, a vertical line is always an x equals. So this is saying we've got a vertical asymptote at -2. So I'm going to go -2, and I'm going to dash my line.
Oh, it's dashed?
Oh, yeah, vertical asymptotes are just dashed because they're like guidelines, Mr. Main. It's a guideline, and we're never going to cross that vertical asymptote. Let's go look at the vertical asymptote of this problem. Again, we're skipping horizontals. Determine the vertical asymptote is what I want to focus on here. Set the denominator equal to 0. When is 2x squared? Whoa, that is chubby. When is 2x squared minus 6x minus 8 equal to 0? And this is why we practice factoring, you guys. What's the first step on the factor flow chart every time? Take out the 2. Take out the GCF. What is my GCF? Is the 2, so what's left?
X squared minus 3x minus 4.
And by doing that, do I get to toot or O-toot now that I've taken that out? It's toot because it's 1x squared, and toot is so much faster. I'll agree. That deserves a round of applause. Okay, but I agree. Toot is so much easier. Guys, toot means what multiplies to be -4 adds to be -3. -4 times 1, -4 plus 1. We agree with that? Okay, so that 2 is chilling. And then 2, we get to go right here. X minus 4, you said x plus 1. Is that what you said? You guys, the vertical asymptotes are whenever the denominator equals 0. This is the denominator, right? We just factored the denominator. When would this equal 0? Is 2 going to ever equal 0? No, 2 doesn't equal 0. Is x minus 4 ever going to equal 0? At 4. And is x plus 1 ever going to equal 0? -1. So this one, we're going to have 2 vertical asymptotes. If you struggled with that step that we just did, set them each equal to 0. And then we would add 4, and then we're going to subtract -1. So we've got 2 vertical asymptotes, one at 4 and one at -1. Because does 2 ever equal 0? Nah, fam. You guys, let's go to our picture. X is 4, vertical line, vertical asymptote. X is -1, vertical asymptote. We are moving. And again, just don't look at the rules. It says determine the horizontal asymptote. Nah. I want us to worry about the vertical asymptote on this one. Vertical asymptote on this is always set the denominator equal to 0. So if I ever write VA, that's just me saying, oh, I'm worried about my vertical asymptote right now. When is my denominator equal to 0? X plus 3, x minus 3. She just did a little difference to squares there. When do each of those equal 0? -3 and 3. Those are my 2 vertical asymptotes. X is -3 and x is +3. -3, this is like Liv's magenta pen, and +3. On this next one, you guys, you still follow the same things. When does my denominator equal 0? Isn't my denominator just an x? When does x equal 0? When x is 0, that's my vertical asymptote. My vertical asymptote is when x is 0. Go draw that in. So to show it, I kind of make sure that my dashes go beyond my graph to help me. This next one says, okay, don't worry about that stuff. Vertical asymptotes on this last one was 0. Okay. Whew. This guy. Let's go find my vertical asymptote. Vertical asymptote, I'm going to write myself a note, VA, is when the denominator equals 0. Do I toot or o-toot? Toot, because it's 1x squared. You guys, what multiplies to be -6 adds to be 1? 3, yeah, 3 and a 2. So I get to say x plus 3, x minus 2, because multiplies to be a -6, and then adds to be a positive 1. I agree, DM. You guys, when does that equal 0? Yes, sir. Those are my two vertical asymptotes, -3 and 2. You guys, I'm going to go to -3. I'm going to go to 2.
Am I the only one smelling strawberries right now?
Okay, something we got to do now. Now, here's the deal. We're good on vertical asymptotes. I do want to practice finding the whole, okay? And a whole is what we got to do and see if the top and the bottom functions have the same factor. So let's do it on this one, then I'll go back to that. So you guys, we got to factor the top as well now. So can we toot or o-toot the top? What do you think? Toot. All right, so let's toot the top. T-O. What multiplies to be 3 adds to be 4. 3 times 1 is 3. 3 plus 1 is 4. So here's what I'm going to do. X plus 3, x plus 1. That's my top. On my bottom, we already factored that. X plus 3, x minus 2. I just brought that over. My bad. I shouldn't have gone to my graph. Ooh, Liv is going to be mad because she did this in pen. Ooh, she's going to be mad at me. Here's the deal. I was supposed to look at our holes. You always do the hole first. Here's a hole. How the heck do we get a hole? It says whenever the numerator and denominator have a common factor, meaning these both have an x plus 3 on the top and the bottom, boom, we've got a hole. Whenever the top and the bottom have the same thing, we've got a hole when that factor equals 0. So I'm going to say we have a hole. We have a hole. When that factor equals 0, so that hole would be when x equals -3. Oopsies. So I don't have a vertical asymptote there. I've got a hole when x is -3. Oh, geez. Oh, geez. Oh, geez. Oh, geez. So here's what I would do without a pen. If you did it in pencil, I want you to get rid of that vertical asymptote at -3 because there's going to be a hole there, and I'm going to explain that a little bit more. So what happens is we always factor the top and bottom. Cross out any common factor. Do you agree what we have left is right here? This is what I need you guys to write. We've got x plus 1 over x minus 2 left. This is what dictates every other answer on our page. Every other answer. Meaning, we've got a hole when x is -3. Now, where's my only vertical asymptote? When is my denominator equal to 0? Just 2. Before I had -3 and 2, now it's just 2. So we just have one vertical asymptote now. And then the only other thing I want to do is say, well, where is that hole? That hole is when x is -3, you guys, we plug that back in to what was left. I didn't plug it back in up here. I plug in a -3 into what was left because my hole is going to be at this point. If x is -3, what would I have up top? -2 over -5. -2 over -5, just 2/5. Is that right? So that's where the hole is. -3, 2/5. So now on my graph, I'm going to go left 3, up 2/5. You guys, 2/5 is just 0.4. So I'm just going to go up a smidge, and that's 0.4 or 2/5. That's where we have a hole. We're going to build onto that later. I'm not worried about it. I want us to find holes and vertical asymptotes, and that's it today. Sound good, Gamby? Okay. Let's keep going. This one I already factored for you. Phew! This one I already factored for you. Do we have a hole anywhere? C! Where do we have a hole? Ooh, 4 or -4? 4, very good. So I go like this, boom. I cross those out. I know I've got a hole at 4 something. Here's the deal. Rewrite what's left, people. Y equals x plus 1 over x times x minus 2. Get rid of the hole. This dictates everything now. I don't even look at my original anymore. This is what everything's going to answer. Let's go find the y coordinate of that hole. We get that y coordinate by saying, oh, if x is 4, let's go find the y coordinate of the hole. What would the top be if x is 4? 5 over, if x is 4, 4 minus 2 is 2. 2 times 4 is 8. 5/8? Did I do that right, y'all? Okay, so we're going to go to 4, right 4, and then up 5/8, so it's just a little bit more than a half. And we have a hole there.
It's in place for holes.
Yeah, you guys, here's the hole. We drew the hole, right? Where would my vertical asymptotes be now? Do not go back here. Where are my vertical asymptotes now? When do these denominators equal 0? 2 and 0, right? When does this equal 0?
But wouldn't that be multiplied by the other 0? If we plugged in 2, wouldn't it still be 0?
Totally. So you're saying if x was 2, this entire denominator is 0. Agreed. But also, if x was 0, wouldn't this also be 0? So to your point, Danny, we got more than one vertical asymptote. So I'm going to go to 2, and I'm going to go to 0. Okay, this next one, I need to find the holes first, all day, every day. You guys, in order to find the holes, we got to factor. That's why we practiced it. Toot or O-toot the top. That face is warranted. O-toot's the worst. I hate it. It takes so long, but we got it, people. We got to do it. O-T, O-O-T. What multiplies to be what? Multiplies to be 4 or multiplies to be 8? It needs to multiply to be 8, add to be 9, because we got to multiply my 2 and my 4 together. What multiplies to be 8, adds to be 9? 8 and 1. 8 times 1, 8 plus 1, right? So we bring down our first. So I have a 2x squared. I'm going to say plus 8x plus 1x plus 4. I just replaced my 9x with an 8x and a 1x. If you put your 1x first, that's fine. Our next step might look a little different, but we're going to get the same final answer. Let's group these up. What do 2x squared and 8x have in common? 2x, leaving me with x plus 4. Is that what I have over here? Yeah, and I know my parentheses have to match. So what times x plus 4 is going to get me x plus 4?
1.
A 1. Let's write this pretty. You take the 2x and the 1, and you say times x plus 4. I went psh, psh, and then I went psh, psh. That's what the top factors into. Are we cool with that? So I'm going to write that up here. I'm going to say, all right, the top was 2x plus 1, x plus 4. Is the bottom toot or O-toot?
Toot.
Bless up. Am I right? The bottom is toot, so I can put that answer right here. I'm going to put it right under my new numerator. What multiplies to be 5 and adds to be 6? 5 and 1. So I'm going to say x plus 5, x plus 1. This is my new function. Well, I shouldn't even underline it, but I've just factored it. Do we have any holes? No. So you guys, we literally just say none. There are no holes. That's fine. And this now is what we'll use to answer all of our questions. What are my vertical asymptotes going to be? When do the denominators equal 0?
-5, -1.
-5 and -1, baby. X equals -5. X equals -1. I'm going to go to my picture. I'm going to draw a vertical asymptote at -5 and a vertical asymptote at -1. Okay, this next one. I'm going to just tell you there are no holes because I don't want us to have to practice the difference of cubes formula. There are no holes is what I'm just going to let us know. Cool? Cool. Vertical asymptotes. What do we do for the vertical asymptote? You set what? Don't say it. Denominator. So for my vertical asymptote, set that denominator equal to 0. Yeah, you're saying if I added 1 to that side and I take the cube root of 1, what times itself 3 times is going to get me 1? Just 1. So we're going to go, we've got a vertical asymptote when x is 1. Let's go see if there's a hole. toot or O toot the top? Just 2 because it's 1x squared. What multiplies to be 3 adds to be 4?
3 and 1.
X plus 3, x plus 1. What do we do on the bottom? Can I difference the squares it? Subtracting, are they both perfect squares? Yeah. What does the bottom factor into?
2x minus 3, 2x plus 3.
I always say plus first because I like to say minus. Plus minus. The square root of 4x squared was 2x. The square root of 9 was 3. Ooh, do we have a whole? No, because this one's pretty close. No, they're not even, they don't match, right? So we just have no whole.
Could you pull the 2 out on
I-
both of those?
Oh, you almost had me. I thought we could, but could I pull a 2 out of this? Is because the 2 doesn't go into the 3, we can't. That's a good call, Gabe. Good look out. The vertical asymptotes are when the denominator equals 0. When does 2x, vertical asymptote. When does 2x plus 3 equal 0? When does 2x minus 3 equal 0?
3 halves.
Yeah, x is going to equal, if I'd subtract 3, so negative 3 halves, and x will also equal positive 3 halves. And if you don't want to write it longhand, you could say just x equals plus or minus 3 halves. You know, Plinus. And what's 3 halves as a decimal? 1.5. So I'm just going to go to the right 1.5. And I'm going to go to the left 1.5. And draw my cute little vertical asymptotes.